Okay, going to go through all the questions in the AdMaths mock. Please mark as appropriate, starting with question 1. This is where you have to solve the inequality minus 2 is less than 3x plus 1 is less than 7. Very straightforward here. The principle is exactly the same as with a normal inequality or an equation. You just do the same thing to 3 sides instead of 2. So to get from 3x plus 1 to 3x, we're going to take away 1 and divide by 3. So that's exactly what we do to both sides. We take away 1, we divide by 3. And that's the answer. Question 2. The equation of the line which is perpendicular to the line 2x plus 3y equals 4. Now, if you want to find the line that's perpendicular to this one, you need to find out what the gradient of this is. So the easiest way to do that is to make y the subject. If we bring 2x over or subtract 2x from both sides, we get 3x equals 4 minus 2x. Divide by 3, we get y equals 4/3 minus 2/3 x. And so the gradient is minus 2/3. Now, to find the gradient of a perpendicular line, it's the negative reciprocal. In other words, you change the sign from negative to positive, or positive to negative, positive, and you flip the fraction. So if this is the gradient of the original line, then the perpendicular gradient, I'll call it m dash, is going to be 3/2. So we want a line with gradient 3/2, and which goes through the point 3 minus 1. So then this is a pair of x and y values. So if we take our general equation for a straight line, y equals mx plus c, apologies for the background noise, plug in y is minus 1, x is 3, and m is 3/2, we get minus 1 equals 3/2 times 3 plus c, or 1.5 if you prefer. So minus 1 is 1.5 times 3, which is 4.5, or 9/2 plus c, and so c is minus 1, take away 4.5, which is minus 5.5. So knowing what c is, knowing what m is, we can put those together into y equals mx plus c, and we get y equals 3/2x minus 11/2, or y equals 1.5x minus 5.5. On to question 3. Find the equation of the tangent to the curve y squared, oh sorry, not y squared, that's a whole different thing, y equals x squared minus 3x at the point 4, 4. So to find the equation of a tangent, first of all, you're talking about a curve which is quadratic, so it looks like this, and we want to find the equation of the straight line which just touches the curve at the point 4, 4. That's a tangent. The one that goes perpendicular to that is called the normal. To find the gradient of a tangent, you have to differentiate first. So dy by dx is 2x minus 3. And then we have to sub in the x value, because this is telling us what the gradient is. Dy by dx is the gradient based on what the x coordinate is. Now we know the x coordinate here is 4, so we're going to stick that in. The way you can write that is dy by dx with a little 4 here. That means the value of dy by dx when x is 4. It's obviously 2 times 4 minus 3, which is 5. And so once again, we have the gradient of a straight line, and we know that it goes through the point 4, 4. So we have a value for m, we have a pair of values for x and y, and we sub them into y equals mx plus c to work out what c is. So when y is 4, the gradient is 5, x is 4, and c is going to be 4 take away 5 times 4, which is obviously minus 16. So we get y equals 5x, that was the gradient, minus 16. Question 4. Hopefully most of those were relatively straightforward. The coordinates of a and b are 1, 5 and minus 3, 7 respectively. Now, a quick sketch should let you know that 1, 5 is somewhere over here, and minus 3, 7 is somewhere over here. So we are looking for the point that's halfway between the two. We want, oh, sorry, the midpoint is the second part. The first thing we want to know is the exact length. Exact length is pretty straightforward. If we think of that as the hypotenuse of a right-angled triangle, then the difference between the x values will give us this length, and the difference between the y values will give us this length. Now, this x coordinate is minus 3, this x coordinate is 1, so the difference between them is 4. This x coordinate is 5, y coordinate is 5, this y coordinate is 7, so the difference between the y coordinates is 2. So the length AB, which is the hypotenuse of this right angled triangle, can be found by saying AB squared is 2 squared plus 4 squared, in the same way that a squared plus b squared equals c squared. So that's 20. So AB is the square root of 20, or if you prefer, 2 root 5. same thing. For the midpoint, that was part A. The midpoint, you're just looking for the halfway point between these two. So if you've got an x-coordinate -3 and an x-coordinate 1, the point that's halfway between them will be halfway between -3 and 1, or the average of -3 and 1. That's just 1. Likewise for the y-coordinate, if this point is a y-coordinate of 5 and this one's a y-coordinate of 7, then this y-coordinate will be halfway between 5 and 7, or 6. To find the value that's halfway between them, you just add them and divide by 2. Question 5. The equation of a circle which has its center at the origin and passes through the point 1, 7. Well, you should know that the equation of a circle is given in the, whoops, I was about to write plus there, 1 minus b squared equals r squared, where that's for a circle where the center is at AB and the radius is r. I know that's not a great circle. Never mind. So if we're at the center, the origin, then AB is just the point 0, 0. And if it passes through the point 1, 7, that's indirectly telling us what the radius is. Because if we know it passes through the center, and we know it passes through the point 1, 7, then to work out the radius, once again, we're using Pythagoras to work out how long this radius distance is, because we know that the x distance here is 1, the y is 7, and so the radius squared is 1 squared plus 7 squared, which is 50. So we plug in a is 0, b is 0, and r squared is 50, and we get x squared plus y squared equals 50. There's a more fundamental way of showing that, but that's the general way you work out the center of a circle. Now we're looking for where 2x plus y equals 15 cuts through it. So very roughly, there's a straight line that goes through the circle, and it's going to go through in 2 places. So we are taking x squared plus y squared equals 50, and we're solving it alongside 2x plus y equals 15. Now, this is essentially, whenever you have where 2 curves meet, or 2 lines meet, or a line and a curve meet, effectively you're solving a simultaneous equation, because it is true for every point on this circle that if you take the x-coordinate and the y-coordinate, if you add x squared to y squared, you get 50. 1, 7, and -7, -1, and all the different points on this circle. And it's true for every point on this line that if you take the x-coordinate and the y-coordinate, that double the x-coordinate plus the y-coordinate equals 15. So at the points that are on both the circle and the line, both things are true. We are trying to solve a simultaneous equation. And as you will know, when you're solving a simultaneous equation where one of the things is linear, you make one of the variables the subject. So this says y equals 15 minus 2x, and then you sub it into the quadratic equation. So we are going to get x squared plus 15 minus 2x squared equals 50. And this is going to be expanded by double brackets. I'll just write it as double brackets so that's clear. So people just don't start doing 15 squared minus 2x squared, which is a common mistake. So you get x squared plus 225 minus 60x plus 4x squared equals 50. And again, this becomes 5x squared minus 60x plus 225 minus 50 gives us plus 175 equals 0. We can divide through by 5, which gives us x squared minus 12x plus 35 equals 0. And that gives us x minus 7x minus 5 equals 0 because it factorizes. And so we get x equals 5 or 7. We then need to plug back in to find the y values, but conveniently we already made y the subject. So we know that when x equals 5, y is 15 minus 2 lots of 5, which is also 5. And when x equals 7, y equals 15 minus 2 lots of 7, which is y equals 1. So we get the coordinates 5, 5, and 7, 1. So that's one answer, that's the other answer. Surprisingly, very few people got that answer right. So just be aware of how you recognize what type of equation you're dealing with and how you go about solving it. This you will have done in GCSE, the simultaneous linear and nonlinear. So it's really just recognizing that when you have a line crossing a curve or any situation like that, you're going to be solving a simultaneous equation. Question 6. This is to do with the factor theorem, finding the negative root. So we have f of x equals x cubed minus x squared minus 10x plus 6. If you're using the factor theorem, the easiest thing to do, I'm going to get a calculator out, is to tap this into the calculator and use trial and error to find factors. So hopefully you've got a class whiz or something similar. you go in menu, you go onto the table, you say f of x equals, and you type in x cubed, oops, I've stayed up there, minus x squared minus 10x plus 6 equals, don't bother with g of x because we only need one function, and we'll normally start with minus 5, n5, step 1. We might need to make the step shorter if it's 2x cubed or 3x cubed, but anyway. From this we go through and look, when we plug in minus 3, the answer is 0. Now you have to be careful. There's two pieces of information we get from that. One is that when we plug in minus 3, we know that we'll get minus 3 cubed, take away minus 3 squared, take away 10 lots of minus 3 plus 6, and this is all going to come out as 0, and we should just show that. Now, there's two conclusions you get from using the factor theorem. In this case, the question is asking us to show that minus 3 is a root, so we say therefore x equals minus 3. But we could also use it to show that x plus 3 is a factor of f of x. So if it asked us to do that, we do exactly the same working, but then at the end we would say therefore, this little triangle, x minus 3 is a root of f of x. And you need to make this statement in order to get the 2 marks. That's very important, same as when you're showing it's a factor. Now for the second part, we know that x plus 3 is a factor, and we are trying to find the missing thing that will make it equal to x cubed minus x squared minus 10x plus 6. Now, I'm going to have to pause the video there, and I'll come back for the second half.